To answer this, we first need to define what we mean by knocking the moon off its orbit. If you want the moon to spiral into the Earth or fly off into the dark void of the solar system, you need to change its orbital velocity. The moon is currently cruising at about 1,022 meters per second. To cause a noticeable orbital decay, we would need to change that velocity by at least 1 meter per second. It does not sound like much, but the moon weighs 73 sextillion kilograms. Pushing it is like trying to move a mountain by exhaling on it once. Before you start, you should know that you are violating several physical and legal frameworks. Aside from the United Nations Outer Space Treaty of 1967, which frowns upon environmental modification of celestial bodies, you are definitely ignoring International Organization 60,825-1 regarding laser safety. The Federal Aviation Administration would like a word with you as well, seeing as you are about to point enough light at the sky to make the sun look like a dim candle in a hurricane. A standard green laser pointer has a power output of about 5 milliwatts. Photons have momentum, and when they hit the moon, they exert a tiny amount of radiation pressure. The force exerted by a single 5 milliwatt laser is roughly 16 trillionths of a newton. To change the moon's speed by 1 meter per second over the course of a single day, you would need a total force of about 800 quadrillion newtons. To get that force, you would need 50 octillion laser pointers across the surface of the Earth. To put that number in perspective, if you stacked these lasers, the pile would reach the center of the galaxy. This is roughly 10 quadrillion lasers for every square centimeter of the Earth's surface. The energy required to power them is 250 septillion watts. That is roughly 1,000 times the total energy output of the Sun. The short answer is yes, you can move the moon, but you will be very unhappy with the results. On your way to turning on the lunar shifter, you will encounter some minor side effects. Long before you nudge the moon, the combined energy of 50 octillion lasers passing through our atmosphere would turn the air into a screaming, opaque wall of superheated plasma. The atmosphere would undergo total ionization in a fraction of a nanosecond. Rayleigh scattering would be the least of your worries. The sky would effectively become a solid sheet of nuclear-level heat. The Earth would not be pushing the moon. The Earth would act as the focal point of a supernova-strength thruster. Through the process of thermal expansion, the Earth's crust would likely vaporize and turn into propellant, pushing the Earth in the opposite direction faster than the moon moves. Good news, you successfully changed the moon's velocity. Bad news, the Earth has been reduced to a microscopic speck of glowing dust in the center of a very expensive light show. The moon, now slightly nudged, but mostly just melted on one side, continues its journey through a solar system that no longer contains humans to complain about the tides. If there's any comfort to be had as your atoms are scattered across the local star cluster, it is that for one glorious brief moment, the night sky was filled with a beautiful, blinding glow. Scientists call this Cherenkov radiation when it happens in water, but in your case, we'll just call it the end. Would you like me to calculate what happens if we try to move the moon using the recoil from every human jumping at once?